Welcome back to another video on my channel, math_exe. Today we're going to talk about number patterns and sequences. So a bit of introduction, a sequence is a set of numbers that are in order and have a pattern. So I would give you an example of a sequence. So we have like 1, 4, 7, 10, 3 dots. These 3 dots means that this sequence go on forever to infinity. So what's the pattern right here? Notice that you add 3 to get the next term. So you add 3 to get the next term, add 3 to get the next term, and so on. So another example of a sequence is something like this. So we have 10, 6, 2, -2. And keep in mind, terms can be also negative since there are numbers. So yeah, and this goes on forever, like so. So in this case, the pattern is you subtract by 4 to get the next term. So you get this following pattern right here. There we go. And in this case, in this like playlist, I would say I will only talk about 2 things. First is to analyze a sequence and then like find a pattern, and then from that given pattern you can like find the next few terms. And the second thing is to find the nth term of the sequence. And what I mean by the nth term, I will explain it in future videos, and I will make them separately because there are like so much to cover about it. So I will just go to like how to analyze a pattern, or I would say a sequence. So let's get into some examples. So let's say the sequence, let's starting things simple. Let's say 2, 4, 6, 8, 10, blank, blank. And with this you need to fill the blanks. So I'll give you a short amount of time to answer this question, and you can just pause the video if you want more time. Okay, let's jump into the answer. Notice that you add by 2 to get the next pattern. I mean the next term, sorry. So with this pattern, you can just identify what the next term will be. So you add 2 to get the next term, so that the next term will be 10 plus 2, which is just 12. And then do the same thing on the next term. You'll get the next term will be 14, and then the next term will be 16, 18, 20, and so on. So that's basically how a sequence looks like. Okay, let's move on into slightly tricky ones. So let's see. So we have sequence 1, 3, 6, 10, 15, 21, and so on. And actually I need to make some blanks right here. So filling those 2 blanks, I'll give you some spare time. Okay, notice that the difference between 2 consecutive terms changes throughout the pattern, the sequence, I would say. So the difference in this case is 2, and after that the difference will be 3. The difference after this will be 4, and then 5, and then 6 plus 6. And then therefore we can just simply conclude that the next difference will be 7, and then therefore the next term will be 28. You can do the same for the next one. You get plus 8, and the next term will be 36. And then the next term will be 45, because the difference increases by 1 every time, so the difference will be plus 9. So yeah, that's basically the pattern for the sequence. Okay, the the next example is slightly a bit tricky. So we have 1, 4, 9, 16, 25, 36. Blank, blank. I'll give you 3 blanks for this. Alright, you can either first notice that the differences, again, like the pattern above, increases every time. So I have plus 3, plus 5, plus 7, plus 9. However, notice that these terms are actually representative of the perfect squares. So notice that 1 right here can be written as 1 squared. 4 can be written as 2 squared. 9 could be written as 3 squared. 16 could be written as 4 squared. 25 can be written as 5 squared. 36 can be written as 6 squared. Therefore, the next term will be 7 squared, or in other words, this is 49. The next will be 8 squared, or 64. Next will be 9 squared, which is 81, and the next will be 100, or 10 squared. So I would move into a slightly tricky one. So yeah. So let's say we have 2, 9, 28, 65, 126. There we go. Okay, for this it might not be very obvious. If you try to do some differences, you might still will be a bit confused. So this plus 7 plus 19, it seems like it is random, but it actually isn't. So just stop right here, and yeah, it seems pretty random for most of you. However, notice that we can represent the terms in a slightly different way. So notice that 2 can be rewritten as 1 plus 1, and 9 can be written as 8 plus 1. 28 can be written as 27 plus 1. 65 again 64 plus 1. 126 under 25 plus 1. And notice these numbers represent perfect cubes. So 1 is the same as 1 cubed, 8 is the same as 2 cubed, 27 is 3 cubed, and you can see where the pattern is going right here. So you can predict the next term of this will be, so right, this is 4 cubed for this, 5 cubed, and the next term will be 6 cubed plus 1. 6 cubed is 216, and plus 1 will be 217. Next term will be 7 cubed plus 1. 7 cubed is 343, and then plus 1 will be 344. So this is not really that obvious, but you kind of like have to think outside the box a bit. And this is the purpose of these sequences. So you need to think smart about each pattern, and then try to like interpret this in a different way. So yet another example, let's say 4, 5, 9, 14, 23, 37, blank, blank, blank. Okay, for this sequence, this is actually one of the most I would say famous sequences. So this sequence is actually called a Fibonacci sequence. And this sequence means you get a term by adding the two previous terms. So here's what I mean later. So we can get that 9 is gotten from adding 4 to 5. So you get 9 right here. 14 is obtained by adding 5 to 9. So you get 14. And then you can just see where the pattern is going right here. So the next term will be just 23 plus 37, which is just 60. And then the next term you can just do the same thing. It will be 97. And then the next term you can just say this is just 157. And then the next term you can just add 157 by 97. So that this is the meaning of the sequence right here. So let's jump into even more examples. So let's see. So 2, 6, 18. Okay, so find the next two terms for the sequence. Alright, if you haven't noticed the pattern already, you simply just multiply by 3 to get the next term. So sometimes patterns are not just addition or subtraction, it could be just like multiplication. Sometimes like involves exponents, sometimes involves like roots and stuff. So yeah. So for the next term, you just simply multiply this by 3, and 54 multiplied by 3 is 162. And then the next term, 162 multiplied by 3, you'll get that this will be equal to 486. There we go. So this is the answer for this question right here. So I'll probably do one last example, and then I'll just give you some homeworks for you to practice. So for the last example, it will be a slightly easy one. Okay, so notice the numbers are oscillating back and forth. So we have 8767876, and then the next number would be 7, and it would just simply oscillate from 876, and then the next number would be 7. So yeah, this is the sequence right here. Okay, so this is the last example for this video. So hopefully this makes clear about how to analyze a sequence, and I'll just give you the homeworks in the next page. So hopefully you guys enjoy this video. Please subscribe for more, and I'll see you guys in the next video. Goodbye.